I figured it out. Okay, class 4. So assignment was to sort of send me questions that you guys have now, with the idea that we've sort of waded into what it looks like day-to-day stuff of like a BI analyst. So now there's more context behind maybe why we're doing certain things in SQL. And so hopefully you're getting more comfortable with some of that stuff. Some of the terminologies is starting to make more sense. And so the idea, again, of these questions is to sort of gauge where the class is, for the most part, is for like maybe getting more technical and getting into more of like just the Python side of things. And so there were a lot of questions that were specific to, I think Rochelle said, like your last one was like, how do I get better, like I'd be from a beginner, like all the way up. And so that one obviously is a very good question. The thing we want to do in this class is get you into a position where understanding Python and continuing to learn Python is not a daunting task. Because let's be honest, 4 classes, even if they are 3 hours, coding is a mindset that takes time. And it is like learning a new language. You don't learn a new language in 4 weeks. But you can learn enough to get by. If we're going to Italy or Spain or, I don't know, Japan or Mexico, so any place, you can learn enough to get by. And so that's what we're trying to do with this class, is introduce you to the most common concepts that are applicable into the most settings. And so the answer to that question, and the thing that I would like to try to instill in everyone as this class comes to an end, obviously we're only halfway right now, is to get good at this. You have to do it like every day. Like that's the only way. When you started whatever job you have now, you maybe didn't know exactly what you were doing, but after a while, it's muscle memory. You do, because you do it all the time. So that is how Python is too. If you want to get better at it, you have to do it a lot. If you can find a way to somehow work it into your work, that's what I did when I was doing a lot of my undergrad studies. And then when I moved into the medical field, is they were like, here, use Excel to do all this stuff. And I was like, no way, man. Like, so I forced myself to use Python. I forced myself to use R, forced myself to learn SQL. Those were things that I had all learned in school to an extent. But academia is not the real world. So using that stuff in the real world really daily is what taught me. Those are good. I've worked some of the questions into the lecture today. The other ones are going to come up later on. And then some of the questions that didn't necessarily sort of get answered with the lecture today too, I'll try to touch on those. And then I know Ted had some sort of more healthcare focused questions. Ted, I'm probably going to I don't know if I'll find time to reach out with you like after class at some point to kind of talk through some of that stuff, because I do have some thoughts on that. HIPAA is a beast. And yeah, I don't know. Do you guys know what HIPAA is? Yeah. Okay. Just making sure. Yeah.
So I don't feel comfortable like using Notable to upload anything. Yeah. I mean, it's just, there's limitations, right?
Right. That's a very good point. If you're, especially depending upon whatever EHR you're using, you want to, in your case, you would want to have an enterprise cloud solution, hopefully, or if not, I would, depending upon your place's setup, if they're like completely in charge of your machine, like do you have access to like SQL Server or MySQL? Can you do queries of the data?
I have my own VM, and I have SQL loaded, and I have my databases restored on it.
Gotcha.
For me to just duplicate it, right? So that I can do whatever I want. So,
gotcha.
Yeah, I welcome the opportunity to chat with you if you ever have time.
Yes, I think the big takeaway there would be getting a Python environment on your VM working, so you can use SQL to get your data in, and then you can use a Python environment to do any sort of manipulation, and then potentially push that back to the server, or build a dashboard or something like that. So yeah, I'll put some thoughts together on that and maybe try and find time with you sort of in between class to go over sort of what solutions might look like for that. Because I've done that stuff and it's totally cool and totally fun. And I would love to get you to a point where you feel comfortable with doing that.
I'd appreciate it because like you were saying, right? You want to use this skill every day, but I want to
Yes,
work with my data set of which I cannot share.
totally. Yep. I've been there and
I mean, I could sterilize it, I guess, but it's still,
that's more time that you have to spend doing that. So that doesn't really,
yeah.
Cool.
Thanks.
Yeah. So let's, the first one, Charity got to me first. And so her stuff sort of made it in here. And so basically, again, we've sort of like taken a view and gotten the breadth of the landscape that is sort of business intelligence, data science. Python is a lot different than SQL. With SQL, you had just like a few things to do. You had like select, from, where, group by, and it didn't really change. Maybe there was some joining that got a little tricky, and I don't know if you guys did anything with CTEs, and that stuff can get messy, but like that's sort of it with SQL, right? If you know that stuff, you can figure stuff out. But with Python, it's like, I don't know if you guys have looked at PyPy, the one where we get a lot of our packages. There are so many packages, and a lot of them do the same thing. And so it's sort of tough to be like, where do I even start with this stuff? That's why we've really just primarily been looking at pandas. Again, we saw that it gets 330 million downloads, which is insane. So that's sort of why we're focused on that. Charity mentioned that she looked at a tutorial on YouTube, and the setup was a lot different than mine. It wasn't notebook based, so it was a little jarring to sort of see like, what the heck is going on? So that's something else that we're going to kind of touch on as far as like when we say we're working in notebooks, Jupyter Notebooks specifically, and when we say we're running on Anaconda Cloud, like what do these things mean in the greater context, and making sure we understand what that stuff is. So yeah, but before we get to that, we're going to kind of go over key concepts. So like if terms are here, key concepts are a little bit more up above that, the 30,000 foot view, as people like to say. And so, yeah, when we talk about Python, when we talk about that language, and again, when in comparison with SQL, where we just have a few things we can do, Python, before you add any packages, there is a lot of base functionality that's already there. We touched on that slightly in the first class, but because of sort of how nuanced it is and how it's very tiny, all the little parts are very tiny to sort of build that stuff. It's hard to do something big in just base Python, but it is that sort of foundation that everything is built, the packages are built on, that allow us to do cooler and more important things. But within Python, just again, we're not talking about pandas. We have different data types. We can assign variables, and that's when we just pick, let's say x equals 5. X is now a variable, and we can do things to that. Functions, we've talked a little bit about that in the last period, how you use def and you build a function and you write the code line by line of all the things that you want to go into. We don't need any packages to do that. We can do that in base Python. But then there are all of the libraries, and I use libraries and packages pretty much synonymously. And so that's when somebody else has taken all the little pieces and put them together into something that's a little bit more user-friendly. Let me take a drink here real quick. And so when we understand those sort of base Python things, that's the foundation for sort of how our data literacy works. Because when you think of like regular literacy, it's reading, right? But you're reading in a language, right? And the language is English or Spanish, or I think there's some other languages that people know in this class. So, right. Yeah. So that literacy is completely dependent on your knowledge of whatever language you speak. Data literacy is also sort of very dependent on the tools that you're using to do data analysis. So some people's data literacy is back-ended by Excel. That's how they know it. And they talk about pivot tables and they talk about different things, and that's how their data literacy is in their head, because those are the data tools that they have. That's totally fine, but we can sort of supplement that with what we know about Python and what we know about Pandas data frames, which is sort of our version of Excel, right? It's how we get our tabular data and do summarizes or count, or we select different columns. So with Python as the sort of language that you're using, that informs our data literacy. And so when we say with the ability to read, write, understand, create, communicate data as information, that's all the stuff that we've been doing, right? We've been using Pandas to read in a CSV. We've been running the different functions that we have on that, data type, describe, and whatnot. We've created data, or we've like gotten rid of things. If we had nulls, we've maybe put in the mean as a replacement for that. So we've created data. And then as far as communication goes, that's, the visualization portion, which largely we've just done with Notable so far. But today we will get into actual Python package libraries that allow us to do static visualizations within notebooks. And again, so that's when we think of data literacy, Python is the literate language that we're talking about here. And again, it might not be the only one. SQL is also part of your data literacy, right? When you think of columns, you think of like, if I want to select all the columns, I'm going to select star. And so if that's what you're thinking about when you want to get everything, that's great. That's another language that informs your data literacy. Right. So again, Pandas is sort of the star player that we're talking about here in terms of how we understand tabular data and data literacy. Because this is our tool that we're using to do a lot of the things that I just talked about in terms of read, understand, create. Pandas is what we do, or what we use if we're not using SQL, and we're maybe using SQL to get a big chunk of data, and it's harder to clean with SQL, so we get that big chunk of data and import it into our Python environment, and then we can use Pandas to really get surgical on it. And then data visualization, obviously, we've done a lot of work. We understand our data. We've gotten it to the point where we're tinkering with it with Pandas. It looks good. There's a good insight in there. We've done some EDA. Now we're ready for visualizations. And visualizations isn't always just graphs, right? Maybe it is some sort of a table just with the values on there, because sometimes that's how people prefer to take in information. So that's also something to consider as well, is who is your audience, and how do they like to consume their data. And then problem solving, I have blank because it is what it is, right? That's sort of what I've been trying to push with when we're trying to do something in Python with data. We're trying to solve a problem, or we're trying to create a solution to something that's missing, if we're missing insight or analysis. Okay, so terms, again, very much related to what we were just discussing. Jupyter Notebooks is what we code in, and that is, there are different things to code in. Like as Charity saw, somebody was in an IDE, and they had what is called like a console and like the output. So it'll run everything, where it's not just running chunks. If you're writing stuff in the console or the terminal or something like that, you have to just run it all, and then you get the output someplace else. So that traditionally happens in an IDE. And again, that's accomplishing what we're doing with notebooks, but it's just a different application for writing Python. But again, for everything that we're doing, and even Ted, if you get stuff set up in your VM, you would very much, I mean, you could try different things out for sure, but I think for the sake of like exploring data and doing the analysis that we're doing, I don't think it gets any better than notebooks. That's why, again, it's sort of the industry standard.
Makes sense.
Yeah. And so then Anaconda we're using Anaconda Cloud, but Anaconda is a way to get different coding languages on your computer in a relatively easy fashion. We talked a lot about the command line in the first class, and that is typically how I install Python on my machines. And let me just tell you, trying to do it on a Mac is like, it's tough because you only do it once. Once you get it working, it's not like you do it every day and I get better at it. I do it one time, it works. And if I didn't document it, I'm like messed up. I'm screwed next time pretty much. Which is why having number one cloud solutions, but also Anaconda and those distributions to do Python is much easier. If I install a package that wrecks the dependencies of something else and I mess up my entire environment, I can just go trash that environment, make me a new one. It's similar to VMs, virtual machines. So yeah, Anaconda, just a base application you could install on your computer, and then you could run any version of Python that you wanted, and you could install Jupyter Notebooks. That might be something that we do I know people will be out in the next class, so I'm trying to figure out things we can do that aren't like huge deal breakers or like missing out. So it might be something like that. We'll see. I'm talking to Nate about sort of what he wants to do too. Anywho, so Anaconda is how we get to, in our case, things like Jupyter Notebook, and it also installs the version of Python that we're using. And so then this segues perfectly into Anaconda Cloud. That is a cloud solution. DeepNote, what I'm using right now, is a cloud solution. Notable is the other one that we've been using that is a cloud solution. And those things run Jupyter Notebooks and or other programs as well. But that truly allows us to get reproducibility and a consistent experience across everything that everyone's doing. And then business intelligence tools. These are things outside of Python and Jupyter Notebooks. Tableau is the one that you guys are familiar with. SQL is the one you were familiar with. These are all other business intelligence tools. And then stuff that we have touched on that is good to be aware of, but we don't really, data warehousing and data governance. I guess, did you guys do database building in SQL? I remember hearing about doing like the many to one thing and how that was sort of tricky.
Yeah, that was we had two different shows, so we weren't able to deep dive.
Gotcha.
We were trying to make sure we at least got like the basics and like, do certain functions. So that was like one class.
Gotcha. So you weren't like were you like establishing tables and primary keys and like?
Oh yeah, we did.
Okay.
So
oh, that's fine. I'm just making sure. So when I say data warehousing, that is a portion of that.
yeah.
Okay.
We saw how it flows into the data warehouse.
So you guys, yeah, okay, good, perfect. So you're familiar with that. And then data governance is the people that you work for giving you the okay to build that thing and figuring out who has access to what. Obviously, in the medical field, data governance is absolutely massive. HIPAA's huge. Adoption of new technology can be slow in the medical field because they don't want to even think about getting a HIPAA violation. Like you don't want it. All righty, cool. So we're moving through this a lot quicker than I thought because we are already at the cheat sheet. Okay, so if everybody's on the screen I'm on right now, should be a show sidebar, and there should be, oh my gosh, it's not there. You got to be kidding me. Let me do a refresh.
Was there a second one?
There should be a Python cheat sheet under Notebook. Does everybody see that? So we're going to go ahead and click on that. And we can do, I don't know if this is if this runs in here, I think we're all gonna be running on the same machine. So we're gonna actually download this to your computer. So next to the Python sheet, there should be 3 dots. And you can export as IPyNB. And that will give us, so I'll get out of here real quick. Full screen. Don't open it with anything. We're going to open it with Anaconda Cloud. So now let's all go to Anaconda Cloud. Yep. And mine's already in here. IPyNB, yep. And then so we're also going to get into some statistics and a little bit of machine learning with this. We're not going to get insanely crazy, but I am going to explain the concepts behind some of that stuff. I think you guys are at the point where you being able to understand how the data is set up, it'll make sense how some of these models work. Okay, so when we get into, I have so many tabs open. Tab, 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 tab. Even close this out. So when we get to Anaconda, it's sort of exactly, like it would be like on a regular computer. We're going to go open from path. Okay, that's actually not what we want to do. Oh, that's right. Nope, not that. So we want to click the arrow button that's up here at the top, right underneath. It's underneath run for me. I'm not quite sure where you are. Oh, dude, we have another dude in the chat. Oh my gosh. Buxery? I apologize. I don't know how to say your name properly. My suggestion for you is to go to Anaconda Cloud and sign up and go through the notebooks that we're at right now. They have sample notebooks and they have intro to Python programming, go through all that stuff. We've kind of already done that and we're moving on to some custom notebooks. Okay, so when we click the button here to upload stuff to our session, we're going to try and figure out where that notebook is, where the cheat sheet is. Is everybody able to do that? Yeah, I'm just going to click open and it's going to open it up for me. There it is. And then, yeah, double click on it and it should say Python cheat sheet. Good. Everybody else?
I'm still working on it here.
Okay. Let me know if you need me to troubleshoot for you.
So I hit the plus, right? Or do I hit file?
For me, it's this one. It's a button that has the arrow, and if you hover on it, it says upload files.
I saw now. I'm sorry.
That's all right. I initially was going to file path, but I didn't want to actually write out the path to the file. This is easier. Oh, I have 2 people watching me right now. This is crazy. I'm doubling my audience. I mean, aside from you guys, from everybody else. Exponential growth. What up? Cool. Let me know when everybody's there. Ted, everything work for you?
Yeah, I got kicked out for some reason, but yeah, I have it open and
Cool.
it's all there. So thank you.
Great. So this is sort of the culmination of everything that we've done so far in one notebook. This is, I mean, I wrote this one, so it's going to be different from the other ones. So that's why we downloaded it, so you actually have it. It's not something that's, I mean, you have it in Anaconda Cloud right now, but if you ever lose this environment, you still have this document. And so, yeah, we're going to go through. This is typically how I do stuff. A couple people asked me, like, what's the first thing you do when you sit down to do data science or something like that? Well, number one, have in mind what you're trying to accomplish, right? When we talk about problem solving, I personally sort of think about things from a scientific method point of view, where I'm trying to do things that are evidence-based, and that's how I approach data science and analytics and anything like that. So with that mindset, I've got this iris data, and I want to know all about these. I think they're orchids or irises. I don't honestly. I'll have to find a picture of one. They're flowers. And I want to know about the different types of them, and I want to do analysis, and I want to do potentially machine learning. I want to do statistical analysis on them. And so that's what I'm going to do in this document. I've also kind of like muddied up the data set a little bit because the data set is very clean, but like we want to know how to clean data too. So I've purposely taken some of the data out, and we'll talk about how we do that. So yeah, now I know what I want to do. I want to look at this iris data set. And so the first thing I'm going to do is I'm assuming that I'm going to do some EDA and cleaning, so I'm going to import pandas. I might use Matplotlib. I'm probably going to use Seaborn, so I'm going to import both of those just in case. I want to do some statistics. So SciPy Stats is a great library for that. I'm going to import from that. I'm going to import the stats as stats. Again, we're aliasing everything for the most part. sklearn, scikit-learn is like, if pandas is data manipulation, sklearn is data science and model building. Like I would imagine sklearn has just about as many downloads as pandas, if not more. And so I want to do that stuff. And then specifically, I'm going to take out some different models. I don't want to import everything from some of the stuff, so I'm going to import just a few small ones. Actually, I think that's redundant. I don't know what I was thinking here, but whatever. For the sake of the class, these are the three that I'm going to use, and I'm specifically aliasing them as such so I can use them down below. So I could have just imported everything and called them from sklearn, but instead I'm taking these specific ones and I'm aliasing them so I can use them as such. So let's run that. Get a little star. This one might take a minute. And you might see your disk usage and CPU usage go up because we're going to actually start doing like some somewhat intensive things for our little Anaconda VMs to handle. So yeah, when that star is gone over there and you didn't get an error or anything like that, that means we've got everything in. Cool. So here is our data. We are going to pull directly from Seaborn we imported that. That's one of our visualization programs. We're getting some Seaborn data, specifically the iris data. And I'm going to read that in as iris. But then I'm going to make a copy of it because I'm going to mess around with it. And I want to have the original version just in case I need it. So I'm going to make a copy called DF. That's what's going on here. And then I'm also going to pull out, remember when we pulled out the columns previously, and in this case, I just want the first four. So that's what I've got there, and then we'll just print that and see what that looks like. So cool. And then let's say you guys working right now, if you're in this and you have your cursor blinking, if you press exit and then you hit B, we're going to insert a cell below. So far we've just looked at this stuff, and we're about to mess around with this, but let's just run the whole iris data set, just like that. And there we go. So this is the OG data. We see down here, we get a lot of data right away. We see that there's 5 columns, 4 rows. So we have the sepal length, the sepal width, the petal length, and the petal width. So these are different parts of a flower is essentially what we're getting at. And we have different species. And so that's sort of the first thing that we're thinking about with this data, right? Where this is, I know what we're looking at, and I want to figure out how do these species differ with respect to these 4 things that we know about them. And these are also, just for the sake of understanding what this data is, these are lengths and widths in centimeters. So you kind of get an idea for how big these flowers are. They're kind of cool. Maybe I'll Google one. I'll Google one over the break when we get there and kind of actually put some perspective on this. So yeah, that's what our data looks like. Now I'm going to do something that we have not done in this class. Are you guys familiar? Have you ever heard the term for loops before? So I defined above the column this list of calls, which is these 4 things. And so a for loop is going to say, you're going to designate a variable and it can be anything. Typically people use I because I is like iteration. And you're going to say for I in column. And what that means is every single one of these is an I. This is like I1, I2, I3, I4. So it's going to iterate through all those, and it's going to randomly sample 90% of them and assign them back in. So it's going through all the columns, randomly taking out 10% of them and putting it back together. So I know that that's weird, so I'm going to stop for a second. Because I'm trying to make dirty data for us to clean. Totally. That's yeah, exactly right. It's going to mix things up. Okay. Online folks, Rochelle just said that she got a thing saying like Matplotlib wasn't loading. Just do a full refresh on your page. If that doesn't work, kill all your kernels and just restart kernel or something like that. Okay, there you go too. So you ran the entire document again. So yep, that's another solution. There's more than one solution.
The table that you presented, the first table, is that supposed to be saying like ABC? Because I know mine is different too. Like I don't have, my own goes to 9.
Oh, because you probably did head, right? So what I remember how I said, like if we're in something and we hit exit and you hit A or B, I did B and then I got a new thing and I wrote, so I manually did this. Yeah, that's all right. Let me trash this one. So, and this is just, in my opinion, this is another way that you become quicker with iterating through this stuff. I'm gonna trash this real quick. So, okay, so we just ran this one. I got this data in, I've printed my columns and I'm thinking let's assume that this bottom one isn't here yet. Let's assume that I just wanna look at the data. So you can see the blue is highlighted, meaning this chunk is highlighted. If I hit A, we have a new code chunk in our notebook. And so I just wanna look at iris. And so I'm just going to type it out because that's how we read it in. I could do head if I wanted to, but if it's a small data set, if I just if I just hit shift enter, it's going to give me the first 5 and the last 5 of the data set, basically. But this also gives us the shape too, right? If we did iris shape, 155.
What is it that you do to figure out like the measurements when it's numbers? So we do that last week, like, or last class, so the way to figure out, because you said you knew it was in centimeters.
That's because I'm familiar with this data set. Sorry. Yeah, that was just me giving context. So like with the Titanic data, they had that text document that gave us all the information on that. We could try and track one down for this, just for the sake of understanding what we're doing better, right? I wonder if ChatGPT might know. Tell me about the IRIS data set. It'll probably, I'm serious, it'll probably give you a laundry list of stuff. But yeah, it's definitely, or it's just different parts of this flower, basically. This is like this is a non-depressing, very good standard data set that a lot of people do analysis on because it's really cool. Okay, back to it. So I've just introduced a for loop, and essentially all we're doing is we're randomly sampling 9% or 90% of each column and assigning it back to itself. So like similarly, let's do, just for funsies, I'm going to do exit above. So this is just illustrating what I is. So we've defined I as everything that's in the column, but it's going one by one, right? It's saying for this one, we're going to do this. For the next one, we're going to do the same thing. For the next, until it runs out. So if we just did for I in calls, print I, what do we think is going to happen? Anybody? Bueller?
It's gonna provide you the values.
Yeah, that it's iterating through, right? Yeah, so we just hit that, boom, look, there we go. So that sort of illustrates at a very simple level what a for loop is doing. Now, these loops can get insanely, I mean, with everything with Python can get insanely complex, but just understanding it from a simplistic level, and that is just good knowledge to have as you get into more complex things. You'll feel more comfortable, you'll feel better about writing functions and using for loops by this. So just illustrating it at a simplistic level like this, to me, is really cool. This took a minute for my head to wrap around. Kind of, sort of.
Everything, but you have to tell it what you want it to come from, like everything in the columns or everything in the rows.
Right, yeah. Folks online, Rochelle just said, is it kind of like select star? And I mean, I think it is. I feel like somebody might crucify me for that, but in my opinion, it is. This is iterating through everything in this column, just like select star is selecting everything from a data set. It's assuming yes. So so with that, so this took a minute for me to wrap my head around too, because it's just like, where did this I come from, right? Let's change it to X, and then we'll change this to X. Same thing.
So I is just like
it can
default.
That's what most people use. The same way they import pandas as PD, you can import pandas as like chair or chalkboard if you wanted to. But most people do PD. A lot of people iterate through things with I because I means iterate and things like that. But you can use, when you get to more complicated loops, you might want to call it something different so you don't confuse it with something else that you've looped through previously. Yes. Yep. So loops are amazing for doing complex things that you want to do to like all of your data. But you remember in SQL how you could use a where clause to like filter things out. You could similarly do that in here too. You could say for IN calls, and then you could say where thing contains sepal, it would just print those ones. Yes.
Where does that put an alias? Does it assume the I is also, so like if I put CPAL, Mitchell Lane has, just like, I don't know, just like an example. Does I also assume the alias is still as an I guess? Is it-
Where are you aliasing the columns?
Yeah,
Yeah, actually, we do column renames down below, and we can kind of explore that down there.
does that make sense?
Sort of, I think.
So if I'm renaming SQL, like, you're gonna use as, right? You're
Mhm.
using it as the one column. If I would then make the command of for I in columns print, well, that'd be I in that next, but would it just assume, even though I set an alias to that column, it would just produce that still?
So in this case, we have defined calls up here.
Okay, so it's whatever within that list of columns.
It's whatever, yeah, so I made a list of columns, but this is very good. This is what we want to do. Let's just take a look at what this looks like. Or I do it right there, but if I just run that, it looks like this. If I remove this 0 through 4, we had species on there. And I don't want that in here because I don't want to, I'm creating dirty data and I don't want to lose any of those, basically. So I'm just saying, give me the first 4.
Thanks, that helps.
Good. That's what we want to hear. So that's gone. We've looked at this. We've looked at that.
So I'm gonna ask someone, and this is one of my questions, like, when you were learning Python, of course, you know, academic data is going that way, but were there like other sources you would go to and be like, no, I'm gonna read this, or I'm gonna watch it? Because Ryan Turner has a book, I'm an Audible head, he has a book on Audible, but I didn't know if that was even on the word, or there are other articles or books that you feel like was just,
Yeah.
you know, layman's terms or relatable to where it just helped it like, you know, click.
Right. So for me, that stuff only. So the question was, what other things that I used to learn Python when I was learning it? And it was, I mean, unfortunately, it was like the assignments. Maybe I should give you guys more assignments. No, but I mean that was big for me was just having those assignments, because then there's a problem that I need to solve, right? Then my brain goes into like thinking mode, and I have these tools, and my assignment is that I need to get a visualization of this iris data. And so then it's sort of like, okay, I can go online and look at stuff. There was a book that I read a little bit that is now outdated, because I think it was using like Python 2.7, and we're on like, I think this is 3.9. What does it say? 3.3. It doesn't say. But for me, and sorry, I don't know if this answers your question exactly, but for me, it was having a desire to accomplish something. And in my case, it was homework. And then when I got into the medical field, it was the terrible possibility of having to use Excel for everything. Because I'm not a fan. Have I said that? Okay. But let me kind of think on that. You said you had an Audible book that you might listen to? Well, I mean, I don't know. If you have Audible subscription, that like maybe give it a shot, I guess. I have a feeling that it'll be a lot of conceptual stuff, sort of the stuff that I'm talking about. But again, it might be from a more broad standpoint of like engineering, and not necessarily we're really like rushing through this to understand the business intelligence side of it. So, but yeah, I would go for it. Okay, back to it. So we've used this for loop to essentially mess up our data. So if we run head on that, look, we got some NANs. Oh no, but that's what we want, because I want to show you guys how those functions that we've looked at previously work with this data set. So now we have reassigned DF with, it's a little dirty. We have some missing data. Let's run shape here. Even though we know what it is, I'm just going to do it to check my assumptions. Let's also look at our data types. We got floats. Which for me, I would know that immediately by seeing the decimal in here. Well, I would hope. It could be objects, but now I assumed that it was floats. I've looked at the data types. It is floats. And so let's do the classic describe. And so let's talk about this for a minute. So we have our average, so we can see sepal length is average about 6 centimeters, width is 3 centimeters, petal length is close to 4. But then what's interesting to me is the standard deviations here. Have you guys talked about standard deviations at all? Yeah, it's basically like when we look at this distribution, like what's all the noise around the mean? If everything is mostly around the mean or the median, like how much noise, how much other stuff is there? If we think about this as like a bell curve, like how far does that sort of curve go out? Is sort of like how I visualize standard deviation. So something with a big standard deviation means that those numbers are kind of all over the place. As the standard deviation gets smaller, that means everything is much more similar, right? So just with this describe, we can see like the petal length really varies. It's only close to 4 centimeters, but it's kind of all over the place. And that's interesting to me as I'm doing analysis. But we also note our count on this is 135, but if we scroll to our shape, it's 150. So we're missing, those are the NANs that I incorporated in here. So we're obviously missing data. We can sort of check that out if we want to. With this little guy here, we called this in the Titanic data when we were kind of trying to figure out the missing ages, and then we were trying to figure out like what is body versus other things, and we learned a lot from that. So we're using that same thing. I literally pulled this in from that and just replaced it with this, and we see 15, which we can confirm. 135 plus 15 is 150, which we know that's the shape. So again, those are our assumptions. And just for funsies, let's do another for loop, right? We can do cool things with print statements. We can add in many things. So this print statement is a little bit more complicated, but it's not hard to read, right? Really? I'm calling that a win. So yeah, there we go. We've iterated through all of our columns. We've taken essentially this little guy up here and we've put it down here, and we can see each one has 15 missing. Now that's cool that I did that, but there is also another easier way to do that. You know how we have describe? Info is even cooler. I kind of forgot that it existed, which is why I haven't brought it up. But info gives us even more information. So this gives us the data type. This gives us the non-nulls. It doesn't necessarily give us the nulls, but that's okay. It gives us, we have 4 float 64. So this is like everything that we did up here, and it's been as an info the entire time. But this is also cool because it tells us the memory usage. So like, TED, for instance, if you're pulling in like a massive amount of data from Epic or Cerner or whatever EHR you're using, and you're like, your environment is like chugging and it's going slow. It's like, if it's pandas data frame, run .info on it and see how big it is. I mean, it's one thing to understand the rows and columns, but to actually see the memory usage, the RAM usage that you're using is sort of like, okay, this is too big. Doesn't make sense to do a sampling of this so it is more versatile in my environment. Yeah, so it's pretty great.
More of a database administrators like rule.
For sure, like, yeah, if someone like a DBA database administrator, they know exactly how much data that they have, especially if it's on-prem. They are like, watching every little megabyte, because like if they're not using cloud stuff, then they have a limited amount of space. But for us working in Python, we just need to be cognizant of the amount of RAM that or CPU usage that we have within our environment. So again, we have the little notches up here that sort of tell us our disk usage and CPU usage. And so this kind of gives us an idea of how much we have. And again, we're not working with big data in here. But when you're running locally, you have your own Python environment that is installed via Anaconda or Terminal or whatever. It might be nice. I think there's like I think on Mac you can look at like your system, how like hard it's chugging. I'm pretty sure PCs have one too. I'm not familiar with exactly what it's called. But it's good to look at that. And it's good to close Chrome tabs because I have 1,000 of them open and that eats up RAM. So that's another thing to be cognizant of is when you are doing this stuff, RAM takes up space on your computer. The process, every application on your computer is taking up RAM. And if you're using a big data set on your computer, it's like maybe let's close Chrome or whatever you're using. Probably leave your email open, but like what do I have open right now? Probably too much stuff. I'll have a dictionary open. We'll close that. This is for my sound card, which I don't have plugged in, so we're going to close that. That's music. We'll close that too. So again, kind of down a rabbit hole here, but it's good to be cognizant of your RAM. And this is how we can look to see how much our data frames are, how big our data frames are. Cool. So I think we'll take a break here because this is sort of a good segue into the rest of the data cleaning. So we are at 6:53. We'll go back. We'll start back up at 7:03. Is that cool with everybody? Cool. Whether that? Which one?
Number 8, where it prints I, comma, colon.
That's literally just like whatever you want. That just means it's going to put colon in between the two things. So you could write.
So you couldn't have we left it just.
Yeah, let's just take it out. See what happens. Colon gone. You could put anything you want in here. Anything I want.
They would have had it with or without it.
Yeah.
Oh, I see. Go again back to the colon. Oh, that's what it was. It's just colon is the. Okay. No. Got it.
So there's three pieces to this print statement, right? There's the I, which is just iterating through calls, which we define above as these four things. And then so it's going to do that first, and then it's going to print the colon, and then it's going to look at the amount of nulls that are in the column that it's iterating through with PD is null, and that's going to give true falses back, and then it's going to sum the trues, and that's the 15.
Got it.
Yeah.
Parentheses.
I know. So one thing that you can kind of look at, so if I go to this parenthesis, you see how it's green,
Yeah.
and then it's telling me this is the other one that it's with. So that's super important to think about. Yeah, and some people like rainbow ones. Yeah. Okay, I'm gonna do the banner, and I'm gonna remember to take it down, and I'm not gonna mute this time. I'm doing it. I'm using the whole dice. Let's see if I die.
Right. All these questions. Yes, I have the comments.
Figuring out themselves.
Is it?
I'm like, just like, fine, figure it out yourself.
Anakin didn't come yesterday. Now she's asking all these questions. So we said we're halfway through
This class.
So I think everybody else on the job and so that we're doing, hold up, no.
That's a lot.
I'm like, what am I doing? I'm going to restart.
She said here.
I'm gonna do all of it.
Have any of you guys worked with your SQL since finals?
I tried to keep one. No, I've been trying to think about it. I was like, no, I should probably go look at it before I forget it.
But of course, me being adventurous, I'm going to look for something I knew, and the data is like, that's way too much data in there. Way too much. It has like over 50,000 rows. And it's things that I know, so it was like government data. I know what this is, I'm excited. And then like, after like multiple tries, so I was able to do a schema by myself, was able to retrieve the data myself, and then I was trying to create a table, but I think I had way too much data.
In Python?
No, on SQL.
I have not. I'm like, I don't know.
I think if I had a smaller data, I could probably do it, but now I'm like challenged, I'm like, I'm gonna figure it out. I did reach out to Sam, I'm like, why do you think this is happening? He said, you should have been happy. I'm like, okay, it's me then. Okay.
So I'm like, what do you look at it?
He didn't, I mean, he said that, yeah, it should be.
Yeah.
Probably that's pretty well, actually.
Man, back up to 2 viewers. Woo! Oh, that's not what I wanted. There's slightly bigger. Okay, we're just about there. Turn off my banner. Yeah. Oh, there, now it's gone away. Oh, cool. Okay, that's nice. I didn't realize that. If you hit the whatever thing you're on here on the side, if you click it, then it goes away, and then you have more space, which, at least for the sake of the webcast, is kind of nice. So I kind of stick with that for a minute. Okay, so we have iris data. We have brought it in. I made it messy, but let's assume that that's how it was brought in. We've looked at the shape, we've looked at the data types, we've done describe, we've done info, we've done some for loops to look at our nulls. We found out there was an easier way to do that by just doing info, but that's okay because it's fun to learn how to do for loops. So yeah, now it is the age-old question of what do we do with these NAs, right? And so in previous classes, we have talked about, I think James mentioned excluding at one point. We've also talked about like filling them with a value, like 0, but it all depends upon business context, right? So in this case, we're gonna fill it with mean. That's what we're gonna do. Well, first this is what it would look like to drop. So if we drop it and we run the whole thing, we've lost like a third of our data, right? We had 150 observations, 150 rows with some missing. If we just exclude every single row that has an NA, we have cut off more than a third of our data. And I've talked about this in the past. When we do that, when we lose observations, especially on a small data set like this, statistics get less and less accurate because our sample size gets smaller and smaller. So I'm going to go ahead and make the executive decision that we're not going to drop any NAs. We are going to replace them with the mean. And so, in this case, I'm going to again duplicate my data. So I have my sort of original one to go back to if I ever need to. And there's a couple ways to do this. I typically just assign one. Here's my original DF we have that was missing. I took out the observations. And I'm going to assign it as DF1. Now this is a classic. I don't know if you guys have ever done like homework or worked on a project where like you make a change and you add a little addition and then you get further along and you're like, this is the final one. And then you keep going. It's like final. And so that can happen with data frames and objects in Python. But it's whatever works for you. And then if you're on a team, there may be rules that they have for syntax and stuff like that. So something to just be cognizant of. I did the very original DF1 in this case. So yeah, remember from last class, I don't know if it was last class, maybe it was 2 classes ago. We can do fill NA. So if we take a particular column, oh no, wow. This is cool. I'm gonna have to make another account probably. Lesson learned, upgrade. Heck no, man, I'm out of here. Not that expensive, honestly. The other ones are like $40 a month, so that's nice. This isn't too bad. So yeah, anywho, this should look kind of familiar, right? We're taking a column. Remember, we hit our dot, and it gives us all the things that we can do, and fill NA is one of them. And typically, with fill NA in the past, we've just put like whatever value we want in there. So like with the Titanic data, we put 0 in there. I think it was for like body or one of them we put 0 in. But what if we want the average from that particular column? Well, we can just we can get that average as a value. So let's do some fun stuff here. What do these look like? So for IN, we haven't defined df1 yet, so I'm going to take the ones out, and all I want to do is, what are those means? Oh no. Print. Here we go. That's what we'll be filling them with. And this should look familiar because we did it up here. There's our means, 5.803, blah, blah, blah. 5.830, yeah, that's exactly. So it's like, okay, cool. That's what we're going to fill all the NAs. We're going to fill with respect to the column that it's in. We're just going to fill it with those. So cool. We kind of have an idea of what we're doing here. So we're going to make our new data frame, and we're just going to run it. And let's take a look at what it looks like. Boom. We can see one. We're familiar with this one, right? That's the first one we saw. There's another one. So those were our NAs. So now we have all of our rows back. We were going to lose 50 rows. That's like absolutely a huge bummer. And we didn't do that now. And so let's think back again. We're making a business decision when we do things like this, right? And so let's go back up and compare. If our median is 5.83 and our average is pretty close, standard deviations aren't that bad. Petal length is maybe the only one that is questionable. But these are things to take into account when we're filling things with means or something like that. Like, for instance, if I came up here and this standard deviation was like 200, like, no, we got to find something better to do that. And there are like machine learning options, k-nearest neighbors and stuff like that we could use to implement. So there are other options, but that's just something to be cognizant of as we make these decisions that alter the data like this. So in our case, this is good to go. We filled in the NAs. Our data set's still big. Now this is another sort of business decision. Do we want to drop any duplicates? In our case, our data isn't like indexed with any sort of an ID. So like if we think back to like patients and we want to drop duplicates of those, if a patient is in there twice and the entire row is the exact same, like that was a glitch in the database or something like that, and we want to get rid of that. In this case, we don't necessarily have a ID on these, so it's very possible that two flowers could have had the exact same measurements. So we're just going to take a look at what this looks like. I'm going to run it, and remember, we have 150 rows, 5 columns. I'm going to drop all the duplicates. So yeah, we lost 2 rows. So there were 2 duplicate flowers in there, basically. So I didn't do that. I just ran this to take a look at it. I just wanted to know the metadata because, again, we're still sort of exploring this and trying to figure out if we're, doing the best, if we're cleaning this data in a way that will provide us with the best insight. So we lost 2 rows, but to me, it's like, no, those rows could be legit. There could be 2 flowers that are the same. If we're doing an analysis on them and we decide not to look at one because it's the same as the other, that doesn't jive with me. So I'm not going to, if we want to do, this is another thing that a lot of these things have. So if in place, I have it set to false here. If I were to do this as true, then it would rewrite this df1. In this case, since I'm saying it's false, it's just showing it to me like if I did head or something like that. So we're going to do, so we got our data the way we want it, but we want to make the names a little bit prettier. And we're going to use in place down here. So I kind of dressed this up so it looks a little prettier. But this is the same as if I had it on the same line. Does that make sense? So I have like this big chunk here. And those are the columns. I'm saying columns equal sepal length is now going to be sepal length with capitals and a space. And I'm defining this as such within curly brackets. This is another data form called a dictionary where you have a key and a value. And that's something we haven't touched on very much. We've been more talking about data frames, but in this case, that's what we're using. So let's just print this and see what this looks like real quick. Yeah, so this is, I mean, it looks ugly right now. Oh boy. Okay, whatever. So yeah, I do kind of want to touch on this very briefly. Has anybody ever heard of a data type called JSON before, or JSON? So JSON is similar to something like this. The thing with JSON and dictionaries is they might have nested data within them. So like for a particular value, like sepal length, here it's just associated with one thing. But with JSON and dictionaries, you can like nest. You can do like this equals all this stuff. So that's sort of why we haven't touched it. Data frames are much more elegant and easier to understand. Dictionaries can get very, very messy. But in this case, we have just a traditional, this is very similar to a data frame, right? It's just one thing than the other. And it looks like this is a column, this is a column. So in this case, we're taking these and turning them into this. And so the way that I have this outlined right here is just so it looks pretty. And again, we could just make this one big line, but that's hard to read to me. So I have it like this. And this still runs the same. So if we run this, look, now we've got these pretty columns. And these are going to be better to plot with, right? These are going to, if we're plotting with this stuff, and we used to have like lowercase underscore, and we're showing this to like C-suite boss, like this doesn't really jive. So we want to make it pretty. So we're from our data frame one, we call rename, and then with the columns, we have it in this dictionary setup where we have key and value. Taking this one, turning it to this one. And remember, we're doing in place is true, meaning that I don't have to do the df1 equals df2. In this case, we're saying write this and overwrite the old one, and we're done with it. So df1 is now this guy here. Does that make sense? Okay. All right, so now we're going to move on to visualization. So this is similar to what we did in Notable, but this is sort of this is like the original code, the original plots that sort of like everyone was like, oh, we can take this and make it interactive and do all this stuff. So where'd my mouse go? There we go. So yeah, we are calling SNS, which if we go back to our top here, is aliased for Seaborn. Seaborn is totally cool. Let's do a new tab and look up Seaborn. Yeah. Statistical data visualization. So this Matplotlib is the other one that people use. I prefer Seaborn. I think that their graphics just look a little bit better. But this is something that I would recommend to everyone to go through is look at some of these. I mean, they're just insane. And these should be similar. You should recognize some of these from when we went through Notable in terms of like, there's the violin plot, there's the box and whisker plot, there's one of the weird facet grid things that I thought was kind of cool. Yeah, these should all look familiar. There's a heat map. And if you click on these, it gives you the code to do them too, I believe. Yeah. So I don't know. I'm going to try and just run this. I don't know if it's going to get, I don't know if Brain Networks is part of one of these. We're going to see. Let's do it. Where'd you go? Python, boom, okay. Just gonna go exit, below, paste this in, go. Sick. So there you go. You can take just about anything from the Seaborn website, things that you think are cool. And this is, I kind of think that this is a way to learn Python as well, like in your free time, is like, let's look at these different things. This is actually one we're going to show here shortly. And look how simple this is. Load the data set Penguins. Yeah, Penguins is another cool data set. Maybe we'll mess with that one later too. Regression. So this we could maybe use with some of the stuff I'm doing. Three-way ANOVA, love a three-way ANOVA. Anywho, highly recommend just going through the Seaborn stuff. I've just demonstrated that you can just put it right in the Anaconda Cloud notebook, and all this stuff should run. So there's a lot to sort of pick apart here and maybe change things. Like this is saying style white grid. Like there's probably some other stuff used. So this is using set theme, right? Set theme is right here. Here's all the stuff for set theme. So there's different color palettes. Dark grid, notebook. So let's go back. Oh, why did it zoom in? There we go. So style white grid, style. So yeah, there's all of the different things we could use. Let's try dark just for fun, and then we'll go back to it. Style equals dark. Run it again. Should be dark. Oh, it's not dark. Wonder why not. Okay. Anywho, we've now demonstrated some of the Seaborn stuff. So let's continue on with Iris. Now it did dark, I think, because I set theme. Interesting. Okay, so here we have an interesting visualization. We kind of note here that the different species sort of cluster together when it comes to sepal length and width. And that's, you know, if you're presenting this to, like, I don't know, a botanist, they're going to be like, oh, I already knew that. But it's cool. I mean, you're a lot of times what you're doing with data visualization is you're taking anecdotal business knowledge that everyone's like, oh yeah, we always get sales up in the summer. And it's like, do you just like, where's the evidence and data to support that we always get more sales in the summer? Like if we can actually show that, that's when we're providing like, all right, we have the data to show this. So because of this, we are going to hire, seasonal help and whatnot. And so maybe somebody that's trying to cross-pollinate different types of plants are like, oh, maybe if we take this one and this one, then they'll have like a length and more in the middle. So that's what we're trying to do with data visualization, right? Is we're trying to, analytics and reporting is one thing, but confirming anecdotal business knowledge, or the other side of that is when you disprove anecdotal business knowledge. That's when people get pissed. But it's kind of cool. It's like, you're using data to say, like, we've been thinking about this wrong the whole time. And so that starts a discussion of how we change things. And you did that because you went through the data and you found things that disprove largely thought about things, or largely accepted anecdotal business knowledge. And that, yeah, it can ruffle feathers for sure. So here we go again, looking at petal length. So this is which one had the big standard deviation? This guy, petal length. Is that what we're doing down there? Yeah, petal length. So between the three, we see that there is some, but we definitely see some outliers too, right?
Can you click over it or
No, so with, yeah, so all of these are static. Plotly is something that you can use to do more interactive stuff. It gets a little dicey in notebooks or Jupyter notebooks. It can. Again, that's why something like Notable is nice to do EDA work and actually explore it a little bit more. Yeah, and so now this is one of my like all-time favorite plots. Sorry, I'm a nerd. But I love this because we're getting so much data from this. So if we have petal length and sepal length, again, as our X and Y here, but if we just looked at the distributions of sepal length and we didn't facet it with anything, and we just looked at the distributions, that's what this other graph here would be. So we can plainly see, it's sort of like looking from 2 dimensions to 1 dimension, if that makes sense. It's like these are the 2 dimensions together, but if we looked at them single dimension, is this one is this one, you can glean a lot of information from that data. You can see that they are distinctly different in the different lengths.
So those are 2 different, the sides, they're 2 different.
It's showing the distribution. So this is showing the distribution of only sepal length.
Oh, okay.
See how yeah.
Yeah.
So it's sort of like if you flattened everything and just looked at the distribution, it would look like this. And we can see that in the data, right? We can see that the blues cluster right here, just like the blues cluster right here. The blues cluster right here for sepal length. Similarly, we see that up here. And so, yeah, there is a portion of, I think, education when you're showing this to people. Sometimes you will, similar to how we just had a convo there, trying to like understand what is this showing me exactly. So that's something to be cognizant of as well as you get into showing people visualizations that are that are just different from what they're normally used to seeing. But I love that plot. Cool. So here we get into, we looked at one like this yesterday where I talked about correlation, and one side had the numbers and the other one had the actual data. Let me zoom out here just a smidge so we can see the whole thing. Yeah, so these are the different combinations of like things that we were looking at up there. So let's see if we can find one that we've seen already. This guy, I think sepal length with petal length is this guy, sepal length with petal length. So if we look at this, what this looks like, don't these 2 things look the exact same? It's not faceted, the colors are different, but everything else is the same. So this is a way to look at these things. Like we're zooming out even more. Like here, we were just looking at just the one thing, and we can see the distributions on the side. And if we zoom out even more to see how everything else looks, now we're starting to look at all of the data. We can see the distributions, but what's missing from this is the different type of flower, right? up here, we can see the different types and we can distinguish between all of them. Here, we're just looking at everything. We're not looking by any particular flower, but guess what? We can look by flower. So now we start to get really cool stuff. So this is like everything we just saw in the last one, but in my mind, it's so much more informative. So like, sepal width is really interesting to me. Like all of them are distributed similarly, but then they're very different. Petal length is very different. You can obviously see that the blue ones are much smaller with the length and the petal. So these flowers, the blue ones are going to be much smaller. Yeah, this is, I mean, sorry, I'm nerding out a bit, but these, I love when you can really look at a visualization for a long time because there's so much going on. Like this is interesting to me. This line of green ones, the petal width to the petal length, like that means that the petal length for these ones, there are so many that were just 4. Got to wonder if maybe that's one of the duplicates because they're sort of clustering like that. I mean, we could go back and look at and figure that out if we wanted to, but what questions do you guys have? Somebody? Okay. All right. So that is visualization, or that is these pair plots. And now we move on to stats. We're kind of getting to a point where we're getting into some stuff that is definitely like, to really explain what's going on is like higher level mathematics. But that is also what's cool about this is that you don't have to code out all that stuff. You can just call this stuff and figure out and do it and not have to do everything. So we've done mean before, right? We've seen standard deviation. I could print these out and we could go compare them to the other ones. And that is what we would see. However, if we want to pull out specifically just different columns, here we're saying from within DF1, I want where the DF column equals setosa, I want to pull out just that petal length. So if I run that, this is all we got. This is it just pulled that one thing. Similarly, I want to pull everything that's the versicolor, and I want to compare these two things. So this one we look at ones, there's the mean in there, but man, it's crazy that the mean is so much higher than most ones we're looking at. Anywho, so let's take a look at versicolor. That's that's bigger. So if I want to say that there is a statistical difference between the two petal lengths of the two different species, I might use something called a t-test. I don't want to get into all of the statistics behind what that is, but basically what the t-test does is it assumes that there is no difference between the two sets of numbers that you are comparing. And that's called the null hypothesis. The null hypothesis means that there's no difference between anything. And the main thing that statistics tries to do is they try to say that they want to do what's called rejecting the null hypothesis. If we can mathematically show to like a 95% accuracy or a 95% accuracy that these two things are different, then that's something that is publishable in a paper or something like that. So just by glancing though, we just looked at these two things and one of them was like around 1s with an average of 3. This other one has like an average of 4. It looks like we can kind of say like these things are absolutely going to be different, like just by looking at them. But how do we turn that? That's more anecdotal business knowledge. How can I say for a fact that the petal length of these two flowers is different, and that is a t-test. So we're going to run that. And that occurs right here. I'm calling stats, one of the package. I'm calling t-test, which I believe I aliased as such. And I'm saying compare this one to this one. T-stat is sort of the mathematical, where it falls on the t-distribution, where you don't really care about that. In this case, p-value is the one, though. If the p-value is below 0.5 or 0.05, and that's just an arbitrary number that somebody made up. But if it's less than that, then we can say that there's a difference. Sorry, I know this is getting really heady into statistics, but it's cool that we can do that with Python. So we can look at our t-statistic. Again, that doesn't mean a ton to me. What does mean something to me is if this p-value is really small. Okay. I know it looks like it's 6, but the dash here, this E dash, means it's exponentially higher than that. It essentially means there's 36 zeros in front of this 6. So it means it's very small. So let me see if I can show you an example of that stuff, because it is weird. So if we do 100 E, so this is saying take 100, basically.
But if with the minus, it means
It's yes.
I got that. That probably makes sense. How you wrote it to say that you wanted to compare it, you explain how that makes sense again. Because I'm trying to read it.
Sure.
The T underscore stat.
So for the sake of right now, let's not talk about the t-statistic too much. What we're more interested in is how small is the p-value. The p-value is the one that lets us say with statistical probability that these two things are different. The null hypothesis says that they are the same. If that p-value is below 0.05, then we can statistically say we reject the null hypothesis that they are the same and that they are in fact different.
Yeah, no, I got that. I'm just thinking I was trying to understand that function of that line.
Right here? Yes. Stats. We brought in stats. So if I run stats, tab, I have all of these stats functions that I can use. One of them is t-test, individual t-test. That's where I got that function. Does that make sense?
Yeah, no, I get that.
Okay.
How you wrote it, how you knew to put like a comma into the P value, and then.
Oh, gotcha. Very good question. Very good question.
I was trying to read it, and I was just like, hold on, wait. So I
Right.
was reading a couple of the other lines, and I'm like, okay, I wouldn't know that writing it, but reading it, I understand what's going on here.
That is a very good point. Thank you for bringing that up. Let's take a look at what the output of this function is. So that's weird, but that's the output, is that there is two things, right? I keep wanting to go over here, but I know I'm gonna leave the camera, sorry. The first thing is this test statistic, which is the -19, and then it's also outputting the p-value. So if I want to have these as two different objects, I can assign them as such. So if I wanted to do X, it's going to be the statistic, and Y is going to be the p-value, and I run this. And then I say, I just want Y. There it is. You can assign them to whatever they want, but the output of that function is two different things. But that is, we have never seen anything like that, so I'm really glad you brought that up. Is that what you were getting at? Gotcha. But what is that like? For in this case, it's understanding the output of the function that allows us to do those things. So you may, when you're going through this and you're like, oh, I'm trying to publish this paper, and I need to do a t-test, and you write that stuff and you just think, oh, I just assign it to one thing, and then you try to reference that, it's like, oh, my assumptions are wrong. There's actually two outputs from this. So that just comes with learning the different packages. Again, we can't go through everything, but if you do, you will come across things that output more than one thing that you need to use. So you might put them, we could also, I think we can maybe add them as a dictionary too. There are multiple things you can do. In this case, we're just assigning them to these two things because that's really all we care about. But anywho, what we've illustrated though is when we use that e to the 100, we get big numbers, right? E to 10 is that. E to the negative 10. Oh boy, how low can I go? 8? Nope. 6? There we go. So that's what's going on. This is 100, so it's moving the decimal place from here back 6. 1, 2, 3, 4, 5. Or from the 1, yeah. So anywho, if we know that this is this value, which is pretty small, this one is back 36 spots. So does that illustrate how teeny tiny that number is? So it's essentially saying like, yeah, there's a difference between these two petals. So we've now statistically shown that. T-stat p-value. And then correlation. This is what we talked about when we were doing notable stuff and we were looking at those pair plots, and I was talking about the numbers where the number, like if we can mathematically write a line that is true for most of the data that we're seeing, like that's correlation. Like, is there a correlation between these two things? So let's go take a look. So this is Soda and Visser, and it's the petal length. We've done this up here. Petal length, petal width, petal length, petal length. So if we look at width, we can definitely see Soda and Visser blue. Yeah, that they sort of follow this line, right? Like we're definitely seeing some sort of a trend there, right? So that means that's that sort of correlation. And so this correlation coefficients, or R squared, which is like derived from that as well, goes between 0 and 1. As it approaches 1, that means that the mathematical formula that we have derived from this data can account for almost all of the variation that we see in the data. So when we have high correlation, that's cool. That means we're getting closer to being able to accurately predict stuff if that's what we're trying to do. Cool. Okay, we are going to get into a little bit of machine learning. I'm not going to get into a lot of the statistics, but I am going to talk about training and test sets. The stuff that you guys have maybe heard about, like ChatGPT and how it's trained on all this data, we're going to do that at a small scale here with this data. We're going to make a training set, and it's essentially going to inform the model. Here's everything we know about this stuff. And then we're going to have a test set where the test set goes through the model and we see how close the model does to predicting the different types of flowers based off of our things. So yeah. So this is what Rochelle brought up earlier, where we have 4 different things coming out of this function. So I guess before we get to that, let's talk about X and Y. So this, nope. Okay. So we've taken our iris data. This is our OG data, by the way. This is not with any of the means that I put in, but actually maybe we'll do that after break. Okay. So this is the OG data. We're going to call drop, and we are going to specifically say we want to drop species, the column. Remember our fifth column, and then axis 1 means we're going down, and that is. We could do this similarly. Actually, let's see if that works. So we have x as that. If we define iris cause, oh, it's mad. In parentheses. Oh, maybe it didn't work. Okay, whatever. We've essentially dropped, we have exactly dropped the species column because that's what we're going to try to predict. We are going to say, if given all of these petal lengths, widths, sepal width lengths, just with that, can we predict which species it is? And so like, if we look back here, I mean, these are distinctly different things. Like, so can a model learn enough about that to accurately predict which flower it is? And so we take our data and we have 150 observations, right? We want some of it to train the data or to train the model. And we want some of it to, after the model is trained, we're going to put in data it's never seen before. And since we know the answer to that test data, we can see how well it did. So it's sort of like the model is studying for a test, and then it's the day of the test, and it gets new data it's never seen before. And it's like, okay, sepal length is here. So that means it's going to be this one. So it's literally taking a test. And since we have the actual answers, we can then say, here's what the model said. Here's what we know is true. Now we can accurately say how well the model is doing at predicting this stuff. Does that make sense? Okay, cool. So traditionally, and we're going to be traditional when setting this up, I personally do this a little bit different, but this makes a lot of sense. X in math is always like the stuff that we're changing, right? When people say, f of x equals y, this is very similar to that. X is all of the stuff that is going to be informing what the species is, and the species is y. So y is what is called our independent variable. Y is what we're trying to predict. So that's why y is species in this case. So when we set up our train test split, we're going to have a training for X. So all of the stuff that is informing it, and then we're going to have our Y, which is the answers. So it's saying, all right, typically this one is this one is this one, and the model is going to learn which one is which based off of our X datas. So I kind of show that here. Our training set is 105. We split at 30%. So basically 30% is the test set, 70% is the train set. And that's kind of typical. Sometimes I like to go for a 25-75. You can even go 10-80 or 20-80. And we can do that right here, right? So let's say I want to go 25 instead of 30. I'll do 25. That means our test set will go up, but our training set will go down. So we do that, and there it is. Our test set is a little bit bigger now, but our training set is a little bit smaller. So now we are going to train our model, and it's going to get mad at me probably, and I'm probably going to run out of CPUs shortly. So we might have to move to Notable after this. We'll see. Okay, so that ran very quickly. So the first thing we're going to do, we have our data set up, right? We have it sort of chopped up like, all right, you're the test set X, you're the test set Y, you're the test set train. We have everybody lined up. Now we're going to define the model as logistic regression, which we aliased right here. From linear model, we've imported or we've imported logistic regression. So we're calling that, and that's just a type of classification model. We don't need to get into that huge. And now we're going to say, similarly to how we've been doing a lot of stuff, if we do model dot, we get all these things we can do, right? And in this case, we want to fit the model. And so that's what's going on here. We're taking our training tests, our X, so all the different variations of the pedals that we have, and here's our Y, so that's which ones it is. And it's going to mathematically try and come up with formulas that associate, oh, if it's this pedal length and this sepal length, oh, then it's this one. And it's very brute force mathematics. It's like people used to do this by hand with matrices, and be glad we don't have to do that anymore. So anywho, it is fitting that model. So it is now, this model now has these fitted values from the train and test. And so since we fit it, we can say predict. So predict is something we can call. We're going to put in the X. And so if we just run this, this is just going to give us values of our Y, right? It's just going to give us, yep. So for each, we had 28, right? Or 38. So for each of these 38 different combinations of pedal length and sepal length and width, it's saying these are the ones that it thinks it is. Is it, which one is it?
So actually, we want to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123,
that this is, I don't know why it's saying that. Mine did this too for some reason, but it's still giving you the accuracy. Almost 100%. So that's because we didn't set a seed. So all of these programs are running on, there's no such thing as true randomness within Python. They do it by setting seeds. So maybe after this, we'll set a seed and see if we can replicate everything perfectly.
Okay, but this is, okay.
So that one is not working. Your X needs to be uppercase X.
Right.
Yeah. Python makes you unforgiving. There you go. Yeah. So we've given it a set of data that it's never seen before, based off of the old data, and it's saying, here's what we think it is. And so now let's do some accuracy scores. And that's what this guy here does. We've defined this as y-pred. So this is the prediction of the y variable that we've defined. But we have our actual test ones. So the y test is the actual results from that test set. So if we run it, I got 0.92. You guys might get something different. Sure. So because our Python environments are different, they're running, it may have sampled yours differently than mine sampled mine. Because this train test split does a random sampling. Does that make sense? Right. It might take a different row as like something that it puts in the test set. So what would be cool is if we can actually replicate the same thing on everyone's computer. I think we can do that by setting a seed. Let me double check. I think NumPy does it. Okay. So up here, I'm going to paste. We did not import NumPy. Let's import NumPy. Didn't we? No. P, set random seed 0. Okay. So if you want, we can try to run this to see if we can all replicate the same things on our computer. And all I did here is up in this top Ooh. Up where we imported everything, I just imported NumPy as NP. And then I called random seed 0. You can put anything in here, but if we all put the same thing, that means our computers are all running off the same random number generation, basically. This is going to be bad, but has anybody ever played Minecraft before, or do you know how any of that works? No? Okay. So Minecraft is algorithmically generated, the entire world. So every time somebody makes a new world, it is different from everyone else's. And it does that the same way that this is doing it. It has a seed, and sometimes those seeds are huge, long numbers. But if you started a world and you knew your seed, you could give it to me and I could replicate the exact world. That's the same thing that we're doing here, is if we have the same seed, we should get the same random, when we random sample, it should random sample the same. So I'm going to restart kernel and run all cells, and I'm probably going to hit my CPU limit. Let's see. Oh, 420, nice. All right. Did you run it? So hopefully, what is going on here? Okay, it's taking for a long time. X is not defined. Oh, I didn't fix that one. Let me trash this real quick. So restart kernel and run all cells. Restart. Make sure I'm not missing any slacks. Okay. Did everything run? 433. I'm almost done with my CPU usage. Oh. So let's go boom, boom, boom. Mine's almost at 500, which means I'm going to need to make a new account. It's how much like compute power that I'm using. So because we're getting into like actual linear regression, statistics, and machine learning, it's like it's using more CPU. So that's why it's going up for me. So sorry, what did you say your accuracy was? Cool. So we've replicated. So this is, I mean, this is something that I should have brought up. So I'm glad that you mentioned it. Reproducibility is huge. Like if I made the fact that I made this and we can get the exact same things means like anyone can do it. Like we've made this reproducible, which is like a massive part of data science. And because if I were to give this to somebody and hope to get published and be like, oh my gosh, I can predict what flowers are based off of these different things with like a almost 90% accuracy, that's huge. But if that person then runs my code and they didn't set the seed and it's different, it's like, is this legit? Like, this is different than when you got. So by setting a seed, we're able to get, reproduce that stuff very easily. So let's play around here just a little bit. Let's do.
So when you did this, you pretty much are using the NumPy format instead of pandas, is what you were saying when you put import NumPy as NP? Like how we would say import pandas as NP?
Yeah, I imported NumPy and aliased it as NP. Similarly, we import pandas and alias that as PD. Those things do somewhat similar things, but the only thing that we needed from NumPy is to make sure we're all on the same random number generator. The same seed, exactly. Yeah. So like,
You could have made that seed 10 if you wanted to, or 8, but we all have put the same.
I usually do 777 because I think that's funny. Like you can do whatever seed you want. Yep. If you want somebody else to reproduce your statistics, like they need to be in the same random environment. Yeah, randomness is very strange. It's very hard to reproduce randomness mathematically, which is like cool, but also drives me a little bit insane. Cool. So we're at a good stopping point for a break. I think next we're going to kind of mess around with this a little bit more, and then we're going to go back to one of the data wrangling ones. And probably maybe we'll go through, some people had some questions on the notable stuff. We might pop over there. We ended up going, you guys are awesome. We went through this a lot faster than I thought, and you guys seem to actually get it. So I love that. Cool. All right, coming back at 7:08:07. Oh no, look at this. I'm doomed. What is your guys' CPU usage at?
Say that again?
What's your CPU usage at? Good. Okay. Mine's higher because I was writing and running this over the last couple days. I should have been doing it locally and then moving it over to this, but I think CPU usage is weekly.
Oh, so like once it's.
When you hit 500, then it wants money. Yeah. But at least it's, I don't know, at least we're having consistent experiences and stuff. That's the key. Okay. Let me see when it resets. Oh man, 0 viewers. Tanking now, jeez.
Because you said you're taking a break, that's why.
Oh, that's right. Everybody else is taking a break too. Yeah.
They're taking a break.
I tried to open up these garage doors because I thought it was so nice out, but they're like, yeah, they're super locked down. I mean, it's 60, it's a little chilly, but I wish we could open them. Okay, I actually better make another account. Okay, I'll make a Builder Trend account. I just want to go up there and do that. Oh, verification email. Drat. Okay, I'm gonna unshare my screen for a second. Okay, not sharing. Okay. Oops. Come on, text message. There it is. Welcome to Anaconda. All right. Nuh-uh. You didn't say the magic word. Okay. I like how I stopped broadcasting, but I was still showing you guys my email. That's great. Whoa. Is this? Do you guys have these? CPU should know. They knew. Oh no. Okay. I'm probably gonna have to do this in Deep Note. It might look a little bit different, but you guys should be able to follow along. How did they know? It could be my IP. Do I have Nord on here? I do. No, I don't want to do this right now. Okay, now I'm in Kansas City. Restart. No.
Do you think it'd be like clear your cookies or something like that?
Maybe.
Or what is it?
Clear your cache.
Yeah. One of those should work.
Four weeks. Let's go. Let's try it. Okay. Okay, that's good. That's good. Oh, I never started the ticker. Well, this is good. Yeah. Nice. Good. Good thinking. So now we learned something else in class. If you really need to get back into your stuff or get your CPU usage back, clear your cache and or I'm running a VPN right now too, so it thinks I'm in Kansas City. Shout out to Nord. Nord, sponsor me. Just kidding. And I'll start sharing my screen here. We'll get back to it. I actually, let's see here. This guy. Okay, so I need to re-upload the one we were using. And then the big thing was import ISMP, NP. Is it set seed? Oh, random seed, that's right. Okay, make sure everybody's here.
See, that's what we have at first,
Gotcha.
and then we just run it down.
Yeah, and I was going to use Matplotlib and I just like Seaborn more. So I guess some more like small things. And I think I've talked about this. Commenting code out is really nice. So if I just put the hash in front of that, it now treats it as text. So like a lot of these hashes I use to like write notes, like I'm importing pandas SPD and I'm saying this is for data cleaning and EDA. I'm importing this for visualization. And then I have a little hash to like explain what's going on. But you can also use it to comment out code. This is really helpful when you're debugging like a function. Let's say you have a function that's doing all these for loops and everything and something's not working. So like, just like take a section and comment the whole thing out and just run it piece by piece. And as you can like iterate through it, you can figure out what the problem is and fix it. So commenting code out is very, very good. So if I run it again, I mean, maybe the cache got built, but also I'm not running that right now. So, okay. So we're going to play around. I'm going to kind of illustrate what happens like when, let's say we take out all of our nulls from our data set and then we try to run a model on that. Let's look at what that does to our accuracy a little bit. So I'm going to run my whole thing, run all cells to make sure it's all in my memory and everything. And then I'm going to come and mess around with. Okay, so we previously defined drop NA, and we didn't specifically here. We didn't assign this as anything. I just called drop NA, and it just pulled everything out, and we can kind of see it here. But I didn't assign this to anything. I printed it basically. I didn't use print, but if you just have a data frame and hit it, it's just going to give you usually the first 5 and the last 5 or something like that. So in this case, I'm going to make df2. Dun, dun, dun. Okay, so now we have df2. df2 is our data with no NAs. Okay, so if I come down here and replace iris with, oh, hold on a minute. We also need to run, this is going to get confusing. How do I want to do this? Okay, you guys don't have to follow along here because it's going to get a little tricky. Because we renamed DF1, and that's what our machine learning model is looking for when it's looking for these different, actually, let me see if I can just change it. Sorry. I'm going off the script a bit here. Okay. DF2. DF2. So I've replaced iris with our DF2, which got rid of the nulls, but we didn't change any of the names on it. Remember, like that's what happens right here. We renamed all of our columns. I could run this if I wanted to, but the only thing we're explicitly calling in the model building is species, and it's just a capital letter. And it's a capital S. So all I've done here is made a lowercase s. and it should still run just fine. So yeah, I'm going to run this. It's going to take a minute. Why did you break? What did DF2? What did DF2 do to you? Let's figure out what's going on here. Oh, it did. What? So this is drop an A equals DF2. Why? Did not drop the NAs. Here we go. Okay. I'm not sure. So that just illustrates running everything from the top again. Something in my environment got messed up. So now I have DF2 as my one. We can see, again, we haven't renamed anything. Species is lowercase. So now we will go back down here and we'll try this again. Okay. So what do we know? Remember, we took. All right, it's a nice night. Somebody's having fun. That's all right. We lost a third of our data set, right? Our training set is now 70. Our test set is 30. Maybe we'll take this back down to 25, just to make our test. You want your training set to be sizable. Like it needs to get a good idea of what the data looks like. There we go. 75, 26. That's not too bad. So then we'll run this. Oh my God, is that really my accuracy? My accuracy is terrible. Did I mess something? Is it? I did not anticipate it being this bad. Wow. So this illustrates why you don't want to take out nulls. We had an absolutely wonderful looking. Is this really right? 96 E01. No, never mind. 96. So our model is still doing a decent job. That is impressive. Sorry, for a minute I was like, oh no, it's tiny. But yeah, we just moved the decimal one over and we get closer to a 96%. So maybe we do want to get rid of the nulls. It sort of depends upon you. So you want to go through every possible iteration. But let's one more time. Let's change the seed. So this is also something called p hacking, where people will change the seed until they get the best possible score. And so that's a you don't necessarily want to do that. But just to illustrate sort of what that looks like, let's do it here. And now we have a different random number generation to do this stuff. We had 0.96, we run it again. Now it's 0.88. So it did change. But yeah, that's pretty cool that we can lose. The data is so that flowers are so distinct from one another that even by omitting a third of them, we still get a model that has pretty good accuracy. And so that says that the data is very distinct, and that maybe if we do have nulls in this case, we do want to get rid of them. Cool. Make sure I'm not missing any comments here. 1 second. Everybody's good. Okay, now I think we're going to get into another notebook here. Let me find which one. Can't remember. I have it in my notes. Okay, yeah, we're going to get a little bit more into kind of bigger data sets and understanding a lot of the stuff that we just did, especially with the train and test set. We had a data frame and we were like dissecting it, right? We were saying, I want these 4 columns as my training data. This is the dependent variable or the independent variable. And this is the test set. This is the other. So we're like slicing it up. So this is getting closer and closer to data wrangling. So if you guys want to go in from sample notebooks into Intro to Data Science course, and then we're going to go to number 6, data wrangling. And then you can go ahead, you can run it piece by piece if you want to. I'm just going to run all cells. And now that we have a pretty good idea of what's going on, we're going to go through this document and I'm going to sort of ask you guys, what does this data look like? What are your assumptions about it? And sort of what is the code doing? Because I think we're at the point now where, I mean, you guys were understanding for loops. You were understanding how output from certain things can be assigned to multiple variables. So I think we're at a point where we can kind of go through this stuff and sort of try to understand what's going on. Data munging. I don't think anybody uses that term anymore. Algorithm sorting, parsing, and finally the resulting content data. Yeah. So data wrangling, that's sort of the term. And so data wrangling sort of encompasses like cleaning with a little bit of analysis, and it's kind of like, but it could be like changing the data structure completely to fit a machine learning model. So it's a little bit different in cleaning because with wrangling, we might be altering the core structure of the data set. So this one is looking at customer churn. Have you guys heard that word before, churn, at all? It means like, so it's huge at Buildertrend. It's when somebody stops using whatever thing that they're paying for. So at Buildertrend, we have a software that people use to like project manage on houses. And then like maybe they use it for a while, and maybe they're like, we don't like it anymore, and they cancel their subscription. So that's called a churn. That's where we've lost money. But there's a lot of nuance behind it because sometimes the market changes and commercial or residential builders just might not be doing anything for a while, so they just don't want to pay for something that they're not using. So it's good to understand client base from that point of view and understand churn from that point of view as well. So in this case, we are looking at customer churn model. This is where I wish that we had the Titanic text to give us more info about this. But we have a lot of information here. We have international plans. So this is cell phone data. I remember this. Okay. So we have a lot of data. So much so that you see the dots right here. That means that there's other columns that they're just not showing right now because there are so many. So this is a much bigger data set than we're used to. Titanic was like 14 columns. Iris was 5 columns. This one's 21. So this is a lot bigger than we would normally see. So let's talk about sort of with our data literate mind. Let's look at the head of this data. And I know we're not seeing all of it, but let's just does anything jump out at you right away in terms of things that we might want to do analysis on, or things that are like, why do we even have that? There's no way we can do analysis on there. Is anything And there's more than one right answer. Anybody?
I don't know, I just find it creepy that they look at voicemail. Voicemail thing and voicemail thing.
So they're tracking the amount of messages that they do, that they get on that, right?
Night calls versus day. I mean, that's not something you need to do anymore, but
Right.
back in the day, we had to deal with that, remember?
Interesting. Rochelle, what were you saying?
You just saying like what's in top better?
Yeah, like what?
I just thought it was interesting that 3 different states have the same area code.
Can we do the full one?
That's huge. Yeah, that can't be right.
Yeah, I was thinking that.
So,
Back
yeah,
in the day, you didn't have to type the dollar area code unless it was,
right. And my thought is, why do we even, what sort of analysis can we do with a phone number? Like, we could potentially use it as like a customer ID as far as like there's probably just one phone number per row. It would be my guess. But there's no way we can do statistical analysis on phone numbers because they're like, the numbers don't mean anything, right? Now, area code is big, especially because apparently Kansas, Ohio, New Jersey, and Oklahoma all have 415.
I think you could use this now moving forward to see where people are moving to, being that everyone has a cell phone, seeing where they hit towers, things of that nature.
Big time. Yeah. You could do that's, I mean, that gets close to like geospatial data. And that, again, tangent here, but that goes back to your phone always is tracking your data. It tracks everywhere you move. You always have a data footprint. So while this data, I have a feeling this is from like 2007 or something like that. You would think like people studying data science and stuff in like 10 years are going to have iPhone data for everybody and you can track all that stuff. Hopefully not. Hopefully Apple keeps that security or whomever you have, whatever cell phone provider you use. Yeah, but everyone brought up really, really good things. I didn't even notice that the area code for the states were the same. I literally want to go Google that right now to see like, is that true? Like, what the heck? But what you've just done now is you just questioned the validity of this data, which is like huge. That's like what we want to do. Like with our data literate minds, we are now questioning the validity of this data. Let's assume for the class sake that it's okay, even though I don't think it is. Let's continue to go on down. So doing some simple stuff here. Pandas course series. I'm not sure what that is. Interesting. So here we have we have, actually, let's go above this.
415 San Francisco, by the way.
So it's not any of the states on there. Yeah. I wonder if no.
Maybe they used to live in a different state, so they kept their number. I'm not sure people do that all the time.
Yeah, so it says that.
Cell phones, yes. Landlines, no. And
But how do you know?
this could be.
Does it tell us somewhere if it's landline or stuff?
Let's take a look. So that's actually what I want to do now. I want.
I see where it says international. Does that mean their phone would be included? You could have had a landline with international, right?
Yeah, I think so.
Like,
So we see 21 columns. We're not seeing all of them right here. So I want to call data columns values. See a this good guy. So what are we missing? Day charge, evening minutes, evening calls. So we're really just missing one column. So we're seeing most of everything. And there's churn. Oh, so I didn't even scroll over. So right away, churn jumps out to me because it's a string that says false with a period. So that's not even like binary. Like it's not actually true false. What's that? Exactly. Yep. So right away, if I'm making a model where I want to figure out what that is, I'm probably going to convert that to binary. Remember, we did the dummy variables on the Titanic data. I'm probably going to do that here too. Interesting data set. Okay, so we're gonna like go through what is obviously this notebook has already, but we're also gonna ask different questions because this isn't everything that we want to see. But we're gonna see what they're doing and sort of think like what's the mindset here. So account length is the second one. I'm guessing let's assume that's in days. So here you can take account length, specifically call that string within the brackets, and it's going to assign that column to whatever you've defined it as. So you can run head, you can just hit print it by itself. Let's do 20. Now I got showing 20 of them. If we look at the type that this is, it's a series. So when you're calling that, it's a series object. That's not too big for what we're doing right now. But I know that I can also, call this data by doing this. Hello, there it is. And that was, it's not in here. Typically, you can call it like that. Let's see if I can do this. Nope, it's mad at me. Okay, so because there's a space in there, we do have to call it specifically how they did. Previously, with some of the Titanic data, we saw that, oh man, this is not, you could call the object, you could call the column with the period. So there we go. We got that. Let's go. Oh, did I spell it wrong? Yeah, I spelled it wrong. I'm a terrible speller. Oh, come on. Boom. Okay, back to it. Yeah, so when we call it like that, it's technically a pandas series. So that is what it is. We don't necessarily care about that too much. But here, what if we want to now, remember when we were doing the train test split, we were taking just the first 4 columns and assigning the last column as Y. Similarly here, what if we just want some columns from our data set? We could just put them in a list like this and call them as such. So let's see if we can do. So I tried to do this earlier and it didn't work. And I can't remember why. Now I want to test fade again. Oh, of course, now it works. Yeah, so if you want to, we can just take this, put things in a bracket. That's, I believe, is it technically a list? Let's do type calls. It is a list. So yes, putting things within brackets will make a list. And then since we have that defined here, we want to subset the data. We can just put that in there and it will give us just the ones we want. So that's nice. That's sort of what we were doing with the train test split. We were dropping the species column and we were using that species column as our Y. So we like that. And then, yeah, here we go again. Let's check our subset. Data frame, that's what we want. So similarly, we're doing the, oh, this literally just did what I did. Okay, great. Run that. We're just kind of going through desired columns. Okay, so this is cool. We did this earlier. We did data columns, if I can spell right, values. So this is what I did up top when I wanted to see, like, we saw that ... And so I was like, oh, there's something column missing. And it ended up being like evening minutes or something like that. So it wasn't a huge deal, but let's note the output of this is an array and the data type is object. So we know it's a string, but it's an array and we want it to be a list. So we can look here, data column values. Let's do a dot and do tab. Look, we've got more stuff. And if we scroll down to file, to list, to bytes, to string, there's all sorts of things we can do with this thanks to pandas. So if we do that, now we've got ourselves a list. And the lists are easier to work with when we're selecting columns. Yep. This one here? Is it up further? Yep. Is it not, is it different? Is it not working? Is it working? Good. Okay. So yeah, we like lists. Lists are like universally loved by everyone in Python. Arrays, I mean, I don't know. There's a reason for everything. For the sake of what we're doing, lists are great because we can define a list of data that we want to subset within a data frame, and we can throw it in the end of the data frame, and we can get what we want. So that's great. That allows us to, if we think back to our data, area code was weird. Ted found out it was California. So maybe that's not something we want to look at. Phone number in and of itself is not in, I don't think, from like a granular level, I think it makes sense, but I don't know if it makes sense in like a machine learning algorithm. So it's cool. So we can start to look at these things and say, I want this one, I want this one, I want this one, I want this one. And the rest we still have them for reference if we need them. But if we have our desired columns, we can subset them any way that we want to. And that is cool, I think. Okay, so this gets weird. I famously don't love this syntax, but a lot of Python people do. Let's see if we can just run this out center for X and all columns. That's what I thought. Okay, come on now.
Substitute the list with X and on,
So this is
if X not in desired column.
right. So remember our desired columns is right here. And this is saying for X in all columns list, if it's not in desired columns. So, and I know this syntax is really weird. It makes sense if you use it for a while. I'm a PySpark guy, so I very rarely do this. So this is saying it's defining X, similarly how we did like our for loops for I in call list do this. So this is saying X is the first thing that we want. So it's sort of like putting the cart before the horse a little bit. It's saying X is going to be what we get out. and it's saying for X in all columns if that X is not in the desired columns. So it's a weird way of saying in the desired columns, like take out all the ones that are in the desired columns. So, because if we look here, here's our all call list. So desired column has account length, female messages, days called. And so that is in here. Once we take them out, we won't see any of these. Account length, female message, they're not here. So this is basically saying, I want everything in the all columns list except for desired columns. Sort of. I know it, like I said, this is famously one of my least favorite things about Python. I'll probably, if this blows up on YouTube, people will be like, this guy's an idiot, doesn't know Python. It's just that there are many different ways to do this. In fact, can you do minus? No, you can't. You can do that on some syntax. You can just negate the list. Or can you do drop columns maybe? See if that's better. Drop. Nope, it's mad at me. Oh, geez. Yeah, it's very mad at me. Okay. Anywho. We'll get back on. Okay. So basically, this is saying in the all calls list, take out desired columns. The syntax is a little wonky, but that is Python for you. So now we have a sublist though. So we have our lists, we have all columns, we had our desired columns, but now we decided we don't want them. So we've taken them out of our all call list, and that's our sublist. And so then we can run this, and now we've got a new data set with just the stuff that we want. So let's get into slicing. Remember how we can do head? And that'll give us 10. So starting at 0 to 9 is 10. We can do that more programmatically if we just put in the index that we want. Actually, was that different? Let's compare here. Kansas, Ohio, 128, 107. Okay, so when we slice this, we're just putting the range of rows that we want, right? And we're starting at 1, but what did we notice when we did head? When we did head 10, it started at 0, right? So by starting at 1, we're technically missing that first one. So if we do 0, we should see Kansas in our number 1 spot, and there it is. So that's, again, something to be aware of. Indexing starts at 0, typically for most things. But this is a cool way to slice up our data. And again, we can do it anywhere. So let's do it here, 10 to 35. We're starting at 10, we're ending at 35, 34. And so this sort of, there's like, I think it's called the fence post theorem or whatever. We're saying we want 10 to 35, but it's only going from 10 to 34. just the same way that we went from 0 to 9, and that's 10 observations. 10 to 34 is 35 observations because 10 counts as technically 1. So that's why it says 25 rows. Similarly, we can just not put anything. So this is actually wrong. So this says this to 8 is equivalent to 1 to 8. But if we do 1 to 8, I think we lose the top one. Yeah, we do. So we just found an error in this Anaconda notebook. This is not equivalent to, it should be 0 to 8, yeah.
I'm talking about why does the dad record is like math, statistics, and that's the ratio of this to this. So I'm like, why is it the column type ratio?
Yep.
One group.
Yeah, and that there are like certain things about Python syntax as you get more into it that just seem ugly. Like just having a semicolon right there with nothing in front of it to me is just like, it's like nails on a chalkboard. It just looks strange to me. And then similarly, if we don't, so up here we didn't put anything in front of the comma, so it assumes that it's 0. Oop, that's not right. Similarly, if we just put something up front and we don't put something behind the semicolon, it just goes till the end. So in this case, we know we end our data at 3,332. So if we just take it from here, it's just going till the end. So that can be helpful in different situations when you're slicing data and looking through stuff. Cool. So now we're getting into, this stuff is going to be closer to where clauses in SQL. And we'll go through this and then we'll probably call it a night. Well, we'll see if people have questions. That's not it. Let's say that I only want data where the day minutes, so the amount of minutes that they're talking during the day is above 300. I can literally say, well, let's take this one step further. So here we have just a mathematical equation, right? Take all of the data from day minutes, and I want a true or false on how many of them are greater than 300. So if I just run this, that's what I get, right? I get every single observation and how many of them are above 300. This isn't terribly useful to me just like this. But if I take these true falses and I subset my data with it, suddenly I've got something way cooler. So looking at the shape, now I have 43 observations. So let's go ahead and do data. Let's just data 1. Here we go. So we can see our day minutes are all above 300. And we were able to do that with this right here. And that just, all that does is pass in these Booleans, and where it's true, we get that data into our subset. Does that make sense? And then we can do that. Again, this is similar to where clauses in SQL, right? We can say where X is greater than 5, or where Y equals yes, or something like that. It's that same sort of, oh, this is a lot. Let me take this out. It's that same sort of thought process for filtering data. So state, New York. Let's see what we got here, data 2. There we go, nothing but New York. 415 area code. What's going on, New York? Maybe they have more than one, but how is 415 everywhere? I gotta look. San Francisco Bay, what the heck? Maybe you guys are right. Maybe this is data from San Francisco and they're putting like their hometown. I don't know. That's just insane to me. Oh boy, I have too many of these things open. Jupyter Lab, cheat sheet. Nope. There we go. Right? Yes. So we can make these as complicated as we want. So if we want just people over 300 minutes and they're in the state of New York, data 3, there we go. We got 2 people. Area code 415. They're transplants from the Bay Area. They're living in New York. They're calling people during the day. What else do we know about these guys? International charges, churn. Yeah, they left. These are so now we're actually kind of getting a little bit of insight, right? Seems like maybe people from New York that talk a lot, they probably run up their bill and they're like, I don't want to pay for this. And then they get rid of it. So we're starting to understand a little bit about this data. When you guys did SQL, did you guys use so in Python, they use the ampersand to do and. In SQL, you'll actually write out AND, right? Did you guys do that? Yep. And then or is the pipe is what they call this thing, I believe. So if we say 300 minutes or New York, now we get a lot more. So let's do data for, I don't want all of it. Let's do head 20. Cool. We got a bigger data set now. Let's go and check churn. Look at this. Lots of trues. Oh, there's some falses. Okay. But that's interesting. Whoop. And you can also compare columns to one another at the row level. So like in this case, we're saying I want only people where the amount of calls they make during the day is greater than the amount of the calls that they make during the night. So this is taking night calls and day calls within a row and it's comparing them. So in this case, for this guy from New York, area code 415, day calls 67, night calls 128. This guy would not make the cut in that subset, right? Because his day calls are less than his night calls. So when do we use this, right? Like, yeah, it's cool that we can do all this stuff, but like, especially in a medical setting, if you want patients of just a particular DRG or CPT or something like that, you can use pandas similar to how you use SQL to just get those people. And like, yeah, you can do that in SQL if you just need that data set, but maybe you're comparing populations. So in this case, we're making different data sets. Each one of these, each time we do this, we're making data 1, data 2, data 3. So we have all these different data sets. And now we can start to run statistics on them and see how different they are to one another. So this is the importance of understanding how to filter and subset your data.
So what would a question look like when someone is talking? You'll just know that it's what I'm supposed to do.
Sorry, say that again.
Like, if from a job, what would my whole request look like to do something like that? Because you're not going to say, hey, they don't know.
Right.
They don't know. They say, hey, figure out if this is true or false. What is a
Sure. Let's say in this case with this data, let's say that churn is really bad. We've done analysis, right? And we see churn is really bad in New York. That means pull everything we got on New York people. Like, give me that data set, and I want you to do analysis on just the amount of night calls versus day calls, and I want you to compare that to a state where churn is really low, right? And so now it's like, okay, so what do I need to do? I need to subset the bigger data set to look at just New York. I'm going to look at the amount of day calls that they might have. I'm going to pull up Montana or something like that where we have not a lot of churn, and let's do a t-test and compare the amount of calls in Montana versus the amount of calls in New York. If those are drastically different, then, or if those are the same, like that says something about the data. Like it's not the amount of calls that is making the churn go down. So let me move to another column, and you can start to go through it. So I guess that's a lot of still you doing the data discovery, but it starts with your boss or whomever coming to you and saying, this is the problem. Like with this, it's like, this is the problem in this state. How does this compare to other states? So then we start to subset. Or maybe, what else do we have?
Well, could we compare immediate? Wish we, if we had more data, the median age or something like that from a census, like in Florida, would you expect more churn due to aging population? So combining it with something else.
Right. That's 100% valid. And that is, boy, I mean, with the phone numbers, you almost think you could maybe get that information. Yeah.
Even if you used high level information for the average age or something like that.
If you could take everybody in New York and understand churn there, and then compare that to the amount, whatever the census is in particular areas, you start to get useful information. Cool. I think we're at a decent stopping point. So I'll kind of take the temperature again. Does this make sense? Does sort of going through the data like this and chopping it up and potentially doing analysis on different sections of it or visualization? Do you guys understand why that could be something that's important with this stuff? Right. Yeah. Cool. Well, there's not much more in this one. It kind of gets more into specific chopping and sort of how you can do that locationally, which isn't. Yeah, let me take a look here. Yep, you can make new columns. Yeah, pretty standard stuff. I guess that's the last thing I think I'll go over because I think this is nice. I talked about this a little bit last time, feature engineering, where here's all the columns that we have, but maybe we can take these columns and create a new column that we think is interesting. So for instance, here we want to make a new column called total minutes, where it's the sum of their day minutes, their night minutes, and their evening minutes. I like that evening and night are different, but whatever. And that gives us the total minutes. And now we have a new column that could be helpful. Maybe it's not necessarily, maybe churn isn't related to the type of minutes as far as day, night, and eve are concerned, but just the sum of those minutes. Maybe this is now useful information that we can use to correlate with churn. So that's feature engineering. And then similarly, they do it with calls here. Maybe it doesn't matter when these calls are made, but what matters is the total amount of calls. And you can add that to your data set, and there it is. Woo! Cool. So we will end there for the night. I know, are you two out on Monday? Is that right? You're out and you're out? Gotcha. Obviously, you can rewatch the YouTube, but I'll try. I have most of Monday done already. I'll try and finish that up and get it to you guys early so you can at least look through it. And then just watch the video if you want. And then if you have questions, just holler at me. Wednesday? Okay. Yeah. Same thing. I'll make sure to have that stuff done so you can at least go through it a little bit earlier. We're probably going to start moving into some of the questions that you guys asked. I think James had one that I think is really good to talk about. It's a little more conceptual, but it's about sort of data integrity. Like right now, we're sort of working with these static data sets. But what happens when there's new data? What does that look like? How do we refresh our data? Is that on like a timer or something like that? So we're probably going to get into that stuff. And I'll go through everyone else's questions too and sort of add that stuff in as well.
Yeah, that's a good question, James.
Yeah. And it's stuff that's something I deal with daily. So I am very happy to talk about that.
Thank you.
Yep. All right. Thanks, guys. Have a good night. I will end stream with 0
Thank you.
viewers.
All right, cheers. Thanks.
Yep. See you guys.